Hey everybody, it's EJ from eyedesyn.com, and in today's tutorial, we're going to be making little bubbles using soft body dynamics inside of Cinema 4D. So we're going to be covering a lot of the basic soft body dynamic options and how to tweak those options to create realistic, bubbly-like movements, again, all inside of Cinema 4D. At the end of the tutorial, I am going to be showing you how to texture that bubble, like the final rendered image that I'll show shortly, as well as how to create a nice shiny gold material. All that and so much more. Let's check it out. All right, so here is our little animation, our bubble animation that we'll be making today, and manipulating some of the soft body dynamics to create bubble-like blowing up through a tube and kind of bouncing around through all these rings and stuff like that. So let's go ahead and create like a really rudimentary version of this. And there's a little hole that our bubbles will blow through and make this little inner part a little bit skinnier. And for us to be able to see this, get our Superman X-ray vision, we're going to go to the Basic tab, turn on X-ray, and now we can actually see inside. Now let's go ahead and grab a sphere and make this small enough to fit, boop, right inside of our tube. All right, and actually let's just make this even skinnier because having it that thick just kind of is confusing. So let's just scale this down a little bit. So we got our sphere inside of our tube and we're looking good. All right, now we can start applying some dynamics to this and seeing what we can do to make this look nice and like a bubble's getting inflated and shooting out the top of our tube. So to have dynamics in real world physics applied to our objects, we're just going to go and apply some dynamics tags under the simulation tags to our objects. And for our tube, we just want it to be collided into, so we'll get a collider body. And for the sphere, we want to have soft body dynamics, so it's the squishy kind of dynamics, so it's pliable, and apply it to our sphere. Now you're going to hit play and you're going to see some crazy stuff happening, and you're going to say, all right, this is good, this is great, let's render this, give it to the client, bam, make some money. Nope. What you actually need to do first is what happens with the default values on the dynamics tag is the shape is the type of shape that the simulation is using, and it's set to automatic by default. What automatic is the most simplest, most calculation light version of dynamics, basically. So it's the fastest and it's the most inaccurate because it's so fast. So what the automatic does is basically like shrink wraps your object and does not take into account hollow bits of your object. So it's not taking into account the hollow hole inside of our tube. So to be able to take into account the hollowness of our object, we just need to change it to a more accurate simulation, which is our static mesh. Because it's not moving, we're going to use static mesh. All right, so now when we hit play, everything's kind of looking good and our sphere just kind of drops. One thing we want to do with the gravity in our scene is we don't want the bubble to just fall. We actually want it to kind of go upwards, like you're blowing a bubble up and outwards. So what we can do is go into our dynamic project settings by hitting Command D and going to the General tab, and here's our global project gravity settings for our dynamics. If we just place a negative, we're actually going to reverse the gravity. So now our sphere's going up, and looking good. Now what we can do is start messing around with the inflation of our object to make this look more like a bubble. One thing you're going to notice is that our sphere is doing something pretty weird. And this is due to the fact that we have a default sphere. If I go ahead to go to my garage shading lines, you can see that because of our default sphere, there's a heavy concentration of density of polygons at the top and the bottom of our object. Now, what happens when soft body dynamics is applied to a sphere is it applies springs to each of its polygons and the edges and the points. So what we actually want to do is make sure we choose a type of sphere that more evenly spaces out its polygons. And one that I found that works the best is the hexahedron. You can see that now we have polygons spaced a little bit more evenly across our sphere here. All right. So now what we can do is, you can see we're not getting that bunching anymore at the top and bottom of our sphere, and that's good. Now what we need to do is apply some inflation. So in the soft body dynamics tab, we have pressure. Let's just give this a value of like 65 and see what happens. And I'll hit play, and you can see that we inflated and it shoots up, and you can see that it's actually not inflated high enough to be able to get squeezed in there. So let me just scale down my tube a little bit more. Now let's see what happens. Now you can see, if I go back to my garage shading, that the sphere inflates and kind of squeezes up the tube. Now, one thing we can do is on both of our objects, or our tags here, our dynamic tags, we can go into the collision and maybe bring down the friction a little bit so it slides a little bit faster. All right. So we did that, and it's sliding a little bit faster, and we can also up the pressure strength as well. So now we get it a little bit thicker, but you can see that with all these default settings and just adding pressure, it's really not inflating all that much. It doesn't look much like a balloon. It kind of just looks like a dodgeball is trying to get squeezed through a tube or something like that. It doesn't look as pliable as a very light and squishy bubble, right? So what's controlling all that are the springs, the dynamic springs. And what the springs do is define the structure between all of our lines, edges, and points. And the more springs, the more structure there is, and a little bit tighter and less pliable the object is. So what we can do is start removing the number of springs in the structural, shear, and flexion. Now I covered these three types of springs in previous soft body dynamics tutorials, and I'll link to them here. But basically, the thing you want to know is structural basically maintains the hollow shell, or the original shape shell of the object, the volume of the object. The shear is one that's very important for our bubble here. Is the shear prevents it from folding onto itself, the polygons from folding onto itself. So this one we're going to keep fairly high because a bubble doesn't fold onto itself, right? So we need to keep this fairly high. And the flexion maintains the spacing between each kind of point on each of these polygons. So for flexion and structural, those basically maintain like the actual form. And we're going to remove a whole bunch of springs from these two types of objects, or two types of springs. The shear, again, we want to, relative to the structural and the flexion, stay fairly high. Now, let's see what happens when we hit play. You're going to see that our object stretches out a little bit further because of the fact that there's less of those springs, those structural springs, to keep it nice and tight and together. So we're introducing a little bit more pliability to our sphere here, which is really, really good. And you can see that we're getting pretty close. It looks kind of like a bubble a little bit, but just like when you blow through like a bubble wand, sometimes you have those really long balloons, right? Or bubbles, right? So the one thing we can do to really extend this bubble is to just extend the size of our sphere in the Y. So give it a value of like 6, and let's just increase the size, or the length, or the height of our tube, and we'll hit play. And you can see that things are kind of going a little bit nutty. We just need to reposition this sphere a little bit further to the bottom here. Hopefully it doesn't fall at the bottom. But you can see what's happening. Once it goes to the top, things start to get a little bit nutty. And we get this really spiky thing happening. And one thing I found that fixes this, if I go to my garage shading lines, you can see that we have a dense point at the very top of our sphere here. If I change the segments of my sphere, and maybe bring this down to say 17, especially a subdivision that has a flat polygon on the top versus a point like that, let's see if that actually helps this. Now we're decreasing the polygon count, of course, so we're getting a little bit more of a chunky sphere here, but one thing we can do is we got rid of that pointy bit, but the one thing we can do to smooth things out is just placing the sphere under our subdivision surface. So let's rename this bubble, and we'll name this bubble subdivision surface. And now you can see that we're kind of looking like we're kind of inflating a nice balloon here. Or a bubble. I'm going to keep saying balloon, but it's a bubble. Sorry. All right, so one thing we can do is stretch it out even more and see what happens here. So now we're making this inflation a little bit longer. So there's more of that kind of development of that little bubble happening here, which is looking really nice. The one thing that you can kind of see right off the top, actually it's looking good now. You want to make sure that you're not having any collision or intersection between the polygons here. I thought I saw some, but I guess there isn't any so far, which is good. So we have this. The one thing we can do is then start messing around with some of these other settings here. So the one that I like to up is this elastic limit. And basically what this means is the limit of how far these structural springs can kind of stretch. And for a bubble, see, I'm trying doing it again. I want it to stretch a little bit further than it typically would. Okay, so that kind of helps it a little bit. The one other thing that I want to try to limit is, you can see right here, these little stretch things, which for a balloon, and I meant to say balloon this time, that's actually good, but for a bubble, you really don't want that too much. So one thing I like to change is the damping. The damping is pretty important with the springs. So you have the springs, and the most amount of spring, and the more springs you have, the more structure and the more definition on your soft body dynamics. And the damping actually controls how fast the oscillations of those springs springing around dissipate and lose strength. So one thing we can do is maybe up the damping on our shear so that once it flies out, and especially with the pressure damping, once it explodes out with the pressure, that introduces some springiness to the object. So sometimes upping the damping on the actual pressure helps a little bit there. Let's see what happens if we just lower the pressure. And that actually doesn't help that much. Let's actually raise the pressure and see if that helps a little bit too. So you can see that this is looking pretty good. Let's see if we can get away with taking away even more springs. So maybe a 3, a 10, and a 3, and seeing what that looks like. And you can see that now it's a little bit more pliable, but right there, it kind of pops out, right? And this looks a lot more like a bubble. Now watch, once it goes up, it kind of has the wobble, wobble, wobble. I'm adding the sound effects. But it kind of has that nice undulation that you expect from when you blow up a bubble. It kind of, the surrounding bits kind of undulate a little bit, like there's a little bit of turbulence happening there, which is kind of what we want there. So maybe for the shear, we bring that up, and let's just see if we can get away with bringing down the flexion and the structural and seeing what happens there. And you can see that we're getting a lot of these folds here. So actually maybe we need to not go down that far. But maybe what we can do is up the damping of those springs and see if that helps smooth things out and makes it a little bit more like a bubble, which is kind of helping there. So now what we can do, I think that's looking pretty good. One thing we can do is, again, I'm going to my project settings, Command D, going to my expert settings, and just kind of upping up the steps per frames and maximum solver iterations per step to 10 and 20. And basically these are just the calculations, the dynamic calculations per frame, and upping these values slows down the calculation but makes it a little bit more accurate. So we can see if that helps from those little overlaps. You can see it goes a little bit slower, but you can see less of those little tweaks and stuff that's happening there, and this is looking a little bit more like a bubble. So now what we can do is introduce some more objects for it to kind of collide into. Let's get some toruses or tori, I'm not sure what the plural, how you say the plural, and we'll just like rotate these around. So again, rebuilding a very crude version of that original scene that I had there. And to have these be collided into, I'll just take that collider tag from our tube, hold Command Shift and drag, and just copy that to our toruses, and see what happens here. So we have this, let's actually scale these down. So they're a little bit too small. You can see this kind of goes through and kind of gets caught by that second one, which is kind of cool. So we have this going through. Let's actually make this one smaller. So we want this small enough, and actually made this maybe too small. We want this to go through. Yeah, I made that too small. But you can see that it's acting a lot like a balloon or a bubble, where we're going through these little tubes here. And that's looking pretty good. Whoop, cool. So again, you can play around with how much pressure you have. One thing I like to do is with pressure, there is this rest length. And when your object gets inflated, it wants to maintain the original volume. But if you adjust this rest length and up it to say 120%, it's actually rest size scale is going to be 120% more or 20% more or bigger than it was when it was first created. So the size, the surface area is going to be a little bit bigger. So let's see if upping that, it kind of works. So you can see how it got a little bit bigger. Once it inflated, it maintained a size that was 20% bigger than its original size there. So you can play around with that. Again, maybe let's see what happens when we lower the dampening. So you can see way more undulation. You can see that it was trying to stick a little bit more. So sometimes it's a little bit there's too much undulation happening. So you gotta always be careful with that. And again, adjusting the damping. But I'd say that's looking pretty good. That's looking nice. So a nice little bubble. Again, we can play around with our other dampening springs, the structure, see how low you can get with these values. You can see that's too much. There's too much stuff going on. So let's increase the springs here, give it more structure. Needs more structure in its life. But you can see that there's a very thin line you walk with some of these settings, because you change one and all of a sudden things kind of go foobar, and you just don't know why. But manipulating and understanding what all of these settings are goes a long way to getting your nice little bubble. So let's just really quickly just create a nice bubble texture. Well, one that was in my original image here, if you can see right here. I'll just show you how I created this bit here, and maybe let's cover the gold as well. So let's go, and we're just going to go to transparency here, and we're going to just adjust the refraction here a little bit. And you can see that I want to get these really nice distortions happening, so I kind of play around with a lower value like this. And for the absorption distance, this is basically how much light can get through it or absorbed through it, this object, or the thickness. So I'm going to leave this pretty low so I can get more of that color happening. And you can really see, if I bring this down, what's happening here. You really can't tell there in our little viewer there. But one thing I want to do is give it a little blurriness here so it looks a little bit more frosty as it was in this little image here. So looking good. And let's just see what this looks like here. Maybe give it a little bit lesser brightness so you can see through it a little bit less. And maybe add some additive there or something like that. And let's see what that looks like. Let's give it, let's get some other objects in here. So let's just create our HDR Studio rig, and let's just grab an HDRI and just move this down so we just have an environment to reflect, and that's looking pretty good. So now we can see a little bit more of what's happening here. Let's apply some gold to our little torises here. So double click in the material manager, go to turn off color. I just want to work in the reflectance. And luckily there is, if I just delete this specular, I'm going to add a Beckman reflection. Luckily there's all these nice little default Fresnel conductor materials. And if you just go to conductor and go to preset, we have all these different types of metals. So conductor Fresnel is really good for metal. That's something that's very, very shiny and reflective. So you can see that all of these presets are metal. Big surprise. So we can go and just choose gold and say that's, you know, a little bit too light for our taste. We can actually go and just introduce a more orangish color, and you can see that really made that a little bit more orangey. And we can also even pump up the brightness to make this very obnoxious looking kind of a gold. And you can see that that's basically what I did in my original image here. And there you go. There's a bubble blowing through our object. And one thing we can do, I'm just going to go and turn off the floor in the background here on our HDR Studio rig. And this is going to inflate. And the one thing I did to have more bubbles going through this is to just duplicate this whole setup and just keyframing when dynamics was enabled on my second bubble here. So if I go and let me just maybe decrease the size here, and let's go to our garage shading so we can see what's going on here. So there's our second sphere down here. And what we want to do is turn this off. Turn off dynamics, disable it, and then once, let's just play through here. And so we got the one coming through. And once this kind of clears, you can see here's my one sphere, here's the second one. Once this clears and doesn't intersect anymore, we can then keyframe this second sphere and turn on the dynamics, and that's going to turn on the pressure, inflate, and then this should pop up after the other bubble. So now you can get a couple bubbles kind of interacting here and going through. So that's basically how I created my original bubbly composition here, right here. So a couple of them, actually 3 of them, and those were just keyframing the dynamics. So hopefully this gave you enough ammunition to go out there, make some bubbly, nice, fun MoGraph stuff in your own projects. All right, so that's how you can use soft body dynamics to create bubbly things inside of Cinema 4D. So we covered a little bit of the soft body dynamic settings and how to texture some stuff at the very end. If you have any questions on anything I covered, please leave them in the comment section below and I'll get to them as soon as I can. If you make any bubbly looking stuff inside of Cinema 4D, please share them with me. I love to see what you guys are working on. Share it with me on Twitter, Facebook, in the comments, all over the interwebs. Love to check them out. And as always, thank you guys so much for watching these tutorials. If you like this one, please hit the like button. If you like what I'm doing, please subscribe. Always appreciate your support. I'll see you guys in the next tutorial. Bye, everybody.